Hello, this is Sanjana from TELCOMA Technologies. Today, let's have a demonstration of drive test of LTE. Now, drive test is most important part of RF engineering process. That means post-processing and optimization process. So we can use this software for optimization or post-processing processes. Now, we require some software interface to capture all the radio parameters and to check out their values. So in this case, we are using a TEMS Investigation 17.2 to view all the parameters of the radio interfaces. Now, so this is the software interface. Now I have connected a EQ1, that means equipment number 1, which is a Samsung device and LTE enabled device. Now on this device, I am connected to the network, that means the 4G network. Now this EQ1 is deactivated, showing with the cross sign here, so I require to activate it. So here the EQ1, that means the equipment number 1 is activated. I can deactivate this device also whenever I require. Now let's view the software interface. Like here we can have the window, which is a tools panel. Now in the tools panel, we can have the file window, we can space the workspace. Now what is the workspace? The gray window showing here in this part, this means this window is my workspace window where we can place the various parameter windows and then we can analyze. Whatever I am performing action, I can save this workspace with the manage. I can manage my projects. I can have the various settings. I can print this and I can have the preview of this. So in the tools bar, I have record, play, file view, HTML and the key performance indicator reports. Now this is my log file. That means whenever I am driving an area, that means I am capturing an area. So all of the parameters that I am recording in an area will be saved in a file, and that file as a log file. I can open a log file, previous log file for analysis. I can close, I can fast forward it, and I can stop it. Whether I can start a new recording file also. In the configuration window, next which in I can have the various audio indicators. We can have various events definition that can show me the various events that are there like this. So whenever I perform action, the event window will show me the various expression on this EQ1 device. Whereas the audio indicators will tell me that what are the description, what are the parameters which I am playing in this. Now in the control window, which is the next window, I have a monitoring and parameter GSM channel verifications processes. Now this is the presentation window in which I can have the various technologies, like we can record the parameters of CDMA, we can record parameter GSM, LTE, now TDS, DMA and 3G as well. Now our main parameter, like we are performing a drive test of LTE, long-term evolution, so we will discuss the parameters specifically there for long-term evolution. Now these are the various parameters of LTE. Now we have cell search parameters. So why it is showing me the cell search parameter of CDMA, GSM, LTE and UTRA FDD as well as TDD. UTRA as universal terrestrial radio access, FDD as frequency division duplex and TDD as time division duplex. Because we have in LTE we have a backward compatibility, that means we require to have parameters of 3G as well with 2G and CDMA. Now we can see the various data services in this. We can have scanning process, we can have automatic neighbor request, we have discontinuous reception parameters. But the most important parameter that today we are going to discuss in this, that means the very first parameter which we require to have analysis are my radio parameters. Now these are my radio parameters which we require to monitor out in drive test process, which is of LTE. So these are my LTE radio parameters. So on a workspace, I require to capture out the parameters, so I can place this window wherever I want so that I can capture the parameters and I can view the parameter. So here is the position of the LTE radio parameters. I can adjust the size accordingly, whatever I require to capture. Now let's view the various IE as information elements. So now in this information elements, the very first is my mode. So what is the mode of the LTE? So I'm having LTE mode, that means my system is connected or my device or my equipment is connected to LTE network. So I have a mode system as LTE. Now, what is the duplex mode? That means the dual transmission. So, I have a duplex mode of TDD. Now, LTE has an option of working with FDD or TDD mode. FDD as time division duplex, whereas FDD frequency division duplex, whereas TDD as time division duplex. Now, in this area, that means on the cell which I am latched, it is working on TDD mode. Now transmission mode as TM3 values. Now we have like TM0, TM1, TM2 and TM3. So it is as per the diversity and the MIMO configuration used, we have various transmission modes. So transmission scheme, like we have what is the diversity or the MIMO configuration that I am using in my network. So I have the parameter values accordingly. So now in this radio parameters, like we can have another window also which we can view, which is a serving cell. Here now it is connected to transmission diversity. That means my system is having a transmit diversity and the modulation scheme is working on as 16 QAM. It can jump from 64 QAM also and QPSK mode also. Now what is rank indicator as a value of 1? It is showing me I'm physical matrix index has a value of 0. Now we can see the red color and the green color windows in which we can have this UEPUSCH. Now what is PUSCH? PUSCH as physical uplink shared channel transmit power and next one as physical uplink control channel transmit power. Now this shared channel transmit power of PUSCH, whereas PUCCH is of UE, that means the user equipment, and it is showing me the value of values which are in a ranges of green color and the yellow color. Now this color representation, that means if I am having a red color indication, that means my power is very less, the UE is transmitting at a very less power, and similarly both channel, one is there for share channel for data and another one for control channels. So like this on a radio parameters, if I am in a post processing and I am capturing the radio parameters, so I can say that my system is working on a QPSK modulation scheme. It is not working on a highest modulation scheme which is of 64 QAM. So accordingly, I will not get that much data rate as expected. And also my UE is getting sometimes a yellow and a green color, red color, sorry. That means the power parameter of the PUSCH transmission part is not that much good. And similarly with the control channel. Now we have LTE serving cell. Now this in LTE serving cell window, we can see that what are the parameters of the serving cell. Serving cell is basically a cell that is sending me the parameter. That means the cell which is serving me. So on a serving cell identity which is of EQ1, so EQ1 like EQ2, we can have number of mobile device as we require. As we can capture our video on some other equipment, we can capture voice on some other equipment and data on some other. So we can attach number of EQ1. So here we can see the information of this device. Here we have the information window, and this window will show me that these are the including IMSI number and identification of that particular device with version and extended information. That means what are the software installed in this so that it can capture out it. Now in serving cell identity, it is showing me the value as 114. That means this is the identification of a serving cell. Now we have a group identity which is known as serving cell identity of a group having a value of 38. Now, why we have differentiated into group and the cell of the identifications? Because it keep like in a planning we have to identify a cell, and so we require to for identification of a cell and for a group we require to specify some values. So we have having identification of a particular cells. Now we have RRC cell identity. Now RRC as a radio resource control. Now this is basically the identification of a radio resource through which my UE can attach to the network. Similarly, we have identification of E node B and cell, serving cell name. We can have MCC as mobile country code, mobile network code, which is operator specific. Then we have a tracking area code. As in LTE planning, we have divided the areas into tracking areas, and each and every tracking area has its own TAC, which is known as tracking area code. So the tracking area code of my area where I am located is 265. Now, as for the bandwidth, like how much bandwidth we can have for LTE. So serving cell downlink bandwidth is of 20 megahertz. That means the cell which is serving me having a bandwidth of total bandwidth 20 megahertz. Now, as per our calculation in the classes, we have like for 20 megahertz, we always have 100 resource blocks. That means the serving cell which is serving me is having a 100 resource block for the users. Now, next one as downlink EARFCN and uplink EARFCN, which is evolved radio absolute radio access radio frequency channel number. This is a channel number through which we can access the network. So I have a 38950 EARFCN number with their frequency band. That means my area, my serving cell is working on a band number 40, which is of 2400, and my frequency is 2330. Now this MME group and group ID and MME code. MME is basically mobility management equipment, which is the center head. That means the most important controller. This MME having a group ID of 32769 and its code as 205. So this is for identification of a serving cell, the cell which is serving me. So I have placed two windows. First one is of radio parameter and another one is a serving cell. So as I am processing, I am recording, I am viewing the parameters. So I can say that, okay, this is the information which I am getting of the serving cell. I can see the frequency, I can see the bandwidth, I can see what is the band allocated with their ARFCN number. That means channel frequency, as well as we can see the modulation on which my system is working. So in this, like we are having the information of LTE radio parameters. I am connected to a device and device having its information, that means the equipment information. We can have another information which is basically the presentation and the control information, event descriptions, and we can have information elements. In information elements, we have the technology elements. That means as per the technologies, we can view the various information elements. Now we will cover up these information elements in our next class. Today we will discuss these parameters which are starting what are the parameters which we require to measure out. Now, like we have viewed the radio parameters, now we have viewed the serving cell parameter. We can have serving cell CEO also. So I can place here. Now serving cell parameters is a primary cell. That means the sector of the cell which is giving me the primary cell which is giving me the parameters. Like I have secondary cell 1 and secondary cell 2 defined. So we have defined two secondary cells, that in case of primary, what are the nearby secondary cells that can give me the information. Now this is as per the description and the configurations. We can have parameters of the neighbor cell or the secondary cells also to view on. So these are my secondary cells parameter, which we name it as LT serving cell C. Now, what are the next parameters? After this, we require to measure out. This is a serving plus neighbor. Now, we can view that what are the serving and what are my neighbors. So, why we require to define neighbor? Because at the time of the handovers, there it should be definition of a proper neighbor. That means this is my neighbor and I require to latch on a particular neighbor. So, now 38950 is my serving cell EARFCN number. We can view from here also, which is serving cell EARFCN number. This is serving a cell identity as 114. Serving cell identity we can view. We have a group of 38, CI as 0. Now RSRP and RSRQ. Now these are the major parameters in LTE, as RSRP stands for reference signal received power and RSRQ stands for reference signal received quality. Now we have divided, that means as we have RX level and RX quality in GSM. We have, that means that will show me the total intensity of the power as well as the total quality of the signal that I am receiving. Now in LT, as we have reference signal, so we name it as that these are my reference signal received power and reference signal received quality. The name and the distance I have not specified, that's why it is not showing me. So why it is not showing me any neighbor cell on a EQ1, because I am getting a good value of RSRP and RSRQ. And I am not in a handover mode, so that it can show me that okay, now you have to move. That means there should be a handover requirement, because my values are good, I am getting a proper values, there is no need of handover. That's why there are no serving cell, there is no neighbor cell, it is showing me only serving cell parameters. Now if in case my serving cell parameters are very poor, so I can have these neighbor cell information from the neighbor, I can get it that these are the parameters you are getting from the neighbor, so you can latch to a neighbor cell. So this is as a serving cell neighbor parameters, we can view that okay, if there is a problem in one particular area, that there is no neighbor description, I'm not having a handover, so I require to view the parameters which are serving cell and neighbor cell. Now as per the optimization requirement, that means as per my requirement, I have to capture only those parameters. For example, like user is having a problem that it is not having a handover or not getting the neighbor. So we require the parameters that capture the parameters that what are the neighbor parameters why the UE is not having a handover. So we can capture the parameters through this window, which is LTE survey and a neighbor cell. Now, if the values are fluctuating and we require to capture that, we can record the file also, log file, which is our file. And also there is another option that we can take the screenshot of that area. Now with the screenshot, then we can analyze that what are the problems in the particular area, what are the values we are getting it. Now next parameter window in LT, like we require to view. Now this is cell frame timing of the neighbors. Now, as per the ERFC and the cell identity, timing of the reception 1 and the timing of the reception 2. That means I am getting almost similar timing of the both receptions, because we are having more than 2 receivers, or we are having dual transmission diversity mode that is working on diversity. So we have timing of reception 1 and reception 2 on my phone with the offset. If I am having some value differentiation between the two, so I can have the offset values too in this, which we can view from this window. Now these parameters like serving cell frame timing, serving cell CA, serving cell, we have covered up the neighbor and the serving cell. Also we have covered up the radio parameters. Now let's view RRC state. Now what is RRC? RRC as radio resource control and RLC as radio link control. Now what is the status of the RLC and RRC in this? Now when RRC is in connected mode, like I am having a group, that means now at this I am getting a poorer value, so I am having a neighbor cell which we can measure out from this. And the time here it is showing me the offset value between two, because at the time I am connected to the two neighbors. So I am, yes, like this we are having a neighbor cell, so it is showing me the offset between the two neighbors. And whenever I'm not having the neighbor, there is no requirement of the neighbor, I am having only one serving cell. Now we can see that RRC moves to the ideal state. That means we are not connected to, as RRC has two states, one is the idle and one is the connected mode. When we are not having, like we are not using any data services, RRC moves to the idle state. Whenever it's triggered, that means awake, so we go to connected mode. Now next one is RRC cell selection. Now what is RRC cell selection? In RRC cell selection, we can have the value like if I serve something, like I'm connected to one, so I have this RRC connected mode, it's showing me the values. Now RRC connected mode, I serve like anything which I serve, I can have the number of neighbor cell, because now I require to connect to the internet, I require to serve something, I require to view something. That means I require to go or latch to a data center, so RRC is connected. And otherwise, if I place my phone idly, that means I don't want to connect to the internet, so I will have RRC idle state. That means there is no requirement of sending a transmission path. But now why the values are fluctuating, because I started internet surfing on my phone, so I can see the neighbors, I can see the serving cell parameters accordingly, because my RRC goes into idle state. Now this is about RRC and RLC states. Now, okay, if I open up these windows, like at this time I have opened the windows. Now I don't require, if in case I don't require RLC, so I can just cross it. Whenever I require to minimize something, that means I don't want to view the parameter of this, so I can minimize it. So whatever we require, I can place on my worksheet, and accordingly then I can save my workspace. So this is about the 5 parameters that we have discussed of LTE today in our class of demonstration of TEMS Investigation 17.2. We will continue with this software in our next classes. We will keep on updating. Thank you so much.